Okay, today we're talking about scientific notation, and that's a scientific way of saying standard form, basically. It just sounds a bit more posh, so we say scientific notation. But actually, it's a standard form, which basically means A times 10 to the power of K, where A is between 1 and 10, including 1, not including 10. So this is something we saw for GCSE maths, but let me just very quickly show you in more detail. So if you have this question, this example right here, you can imagine there's an invisible dot at the end of the number. So let's just make this dot red. Let's make it red. So imagine the dot is here. And now we want to write this in scientific notation. So imagine there's a dot and a 0 after that. So what we want to do is we want to move this dot to the left so that the dot is actually between 3 and 7, because that will mean that the number we have is actually 3.76, which is acceptable by scientific notation because we want this A times 10 to the power of K, where A is between 1 and 10. So this is between 1 and 10, so we're happy. But now we want to multiply by 10 to the power of something, because we can't just change a number like that. We want to make sure that what we've written is actually the same as what we had before. So basically, if you had 3.76, what would you multiply with to get back to this thing that we had before? Well, you would multiply with 10 to the power of 1, 2, 3, 4, which is how many places you moved the dot to the left to begin with. And now, if you were to put this into your calculator, for example, you would see that indeed it gives you 37,600. So how many places did I move it to the left? 1, 2, 3, 4. That's the power I put here, power of 10. Now, moving on to the inverse problem. When you have this sort of problem here, they give you a decimal, and now they want you to change it to standard form. So small decimal. So you take this dot where it is, and you just start moving it to the right. 1, 2, 3, 4, 5, 6 places to the right until it gets to something like this, 8.6, which is basically a number between 1 and 10. So we're all happy, but now we want to do times 10 to the power of what would give us this? Well, we went 1, 2, 3, 4, 5, 6 places to the right. So now, careful, we want to put minus 6 here in our result. Now, why does this happen? Because we want to make sure the end result, the thing we've written here, when we do this calculation, it will give us the thing we started with. And basically, in order to get what we started with, we want to multiply by 10 to the minus 6, because that will move the dot 6 places to the left, giving us 0.000086. That's pretty much the idea with the super basic questions where you just have to answer something and give it in standard form. But now we might also have some questions where you get to write something in as an ordinary number. Basically, this is the even easier question than the one before. So if they say 3.2 times 10 to the power of 2, usually you can just put this into the calculator. So you just put it into the calculator. So you get 3, 2, 0. Because what happens here is, if you want to do it manually, you move the dot one place to the right, that gives you 32. You move it one more to the right, so that gives you 320. Calculator should really just give you the answer though here. So we don't tend to get questions like this in the IHL. Now this one, the problem with this one is the calculator does not give you the answer. Usually it just gives you the same result back. So if you have 5.76 times 10 to the power of minus 5, how does that work? Well, I'm just going to give you a bit of a tip here. So 5.76 times 10 to the minus 5. Think about it this way, 7.76. And now you have, imagine you've got loads of zeros before it. So you've got zeros, zeros, just put a bunch of zeros there and you'll see what works and what doesn't work. We'll get rid of the extra ones in the end. Now this 10 to the minus 5 business means that the dot from here is going to move 5 places to the left. So 1, 2, 3, 4, 5. So basically it's going to go there, which means actually we will get 0.00000576. And you see that extra 0 I didn't really need in the beginning. I'll just cross it out basically. So if you put a bunch of extra zeros in the beginning, that's fine. You can just get rid of them later. So this would be your final answer. So the only annoying thing, like I said, the calculator doesn't do for you because it tends to give this 10 to the minus something. There is a setting you can play with in the calculator, but I've tried doing that and it just takes so long to change it back to the normal thing. So don't worry, just do it manually. This is the quickest and best way. I'm going to stop recording. I'm going to upload these annotated documents on Classroom, and I'm going to be happy to help and answer any questions you might have.